a limit, what's the first thing you try?
Plugging in.
Okay. And what happens in this case when you try to plug in -1? You get 0 over 0, which is not something that we can determine. So in this particular case, what is the strategy that we would use? Say louder, Trenton. Factor it. What can you do in that numerator, Trenton?
Take out 2.
Okay.
And then factor that with x plus 1x minus 1.
Maybe I could have left for my picture, huh? Okay. Well, what's the benefit to that? If we get this all factored, what can happen? The x plus 1's cancel, and now we no longer have the 0 in the denominator. So now we can actually use substitution, direct substitution. We now have the limit as x approaches -1 of 2 times x minus 1, which would get us -4. Okay. Why am I asking you to do a limit in the middle of our derivatives? Okay, so Unit 3 is the application of derivatives. And we actually have a derivative application that helps us evaluate limits. Okay? We can actually evaluate this limit without having to do the algebra of like factoring and canceling out. We have another way. Okay? So today what we're going to talk about is a method called L'Hopital's rule.
Is it easier to look?
Okay? This, in my opinion, this gives you an easier option. Okay?
But does it work every time?
It only works in specific cases. And we're going to talk about what specific cases those are. Okay? So we did all of this algebra because our limit was 0 over 0. And that is something that we call indeterminate. We cannot calculate what 0 over 0 is. Okay? So L'Hopital, with I think the help of Bernoulli, said, okay, can we have, you don't have to write this down, is there something that we can do besides all of this algebra in order to determine an indeterminate limit? So this is L'Hopital's rule. Okay? When we go to Calculus the Musical, there's an entire song dedicated to L'Hopital. Okay? Yes, we will go to Calculus the Musical in April. It's like,
Will you really?
we really will. Like, this is a real thing.
Oh, I thought you were making a joke.
No, all of us go to Calculus the Musical and get free pizza.
Like it just takes a day.
Free
Like
pizza? This class
Like, you go to first hour, we leave during second hour, we come back during sixth hour, and you go to seventh hour. So you miss second through sixth.
False.
That's probably.
You don't come to school, then you go to musical, then you go home.
If
That
you don't
sounds
have a
pretty
first
good.
and second. All right. So, if you have a limit that gets you either 0 over 0 or infinity over infinity, those are indeterminate, then what we can do is we can take the limit of f prime over g prime. Write it down and I'll talk about it again. Just write it down. In April, we'll go to Calculus the Musical. They feed us pizza, and then there's a calculus piece. So it's like a buzzer round competition, but with calculus problems. That
Is it a good musical?
We take a test to qualify it for it. So like, not everybody's gonna get to do it, but we're all gonna get to watch.
Shucks. Oh, okay, I'll watch.
We all get to watch.
Volunteer to be a cheerleader.
It's like when I in 4th grade they were doing spelling bee, but it wasn't a choice; it was like a qualification. So I purposely spelled kitchen wrong, so I wouldn't have to do it. But it wasn't really on purpose because like I spelled it wrong, and I was like, ooh.
Yeah, I don't get to do it. Okay. So, do you notice how our limit originally is a fraction? Okay. And if that limit goes to 0 over 0 or infinity over infinity, plus or minus, doesn't matter. Okay? These are two fractions that we cannot determine the value of. They're called indeterminate. Okay? So, if we have a fraction limit that gives us this indeterminate form, then we can take that fraction and we can take the derivative of the numerator, we can take the derivative of the denominator, and then try our limit again. Okay? For example, what was our limit from, we had the limit as x approaches -1 of 2x squared minus 2 over x plus 1. Right? Okay, well, if we plug in -1, our numerator goes to 0 and our denominator goes to 0. That's one of our indeterminate forms. So what we can do is we can use L'Hopital's rule to write this as the limit as x approaches -1. What is the derivative of 2x squared minus 2? Over, what is the derivative of x plus 1? Now, we can plug in -1. 4 times -1 over 1 gets us -4.
Ooh.
Is that easier?
Yeah, I like this.
We have to do
But actually, did you know
product.
that Calc is the hospital?
Is it? Okay, I had, so, we do L'Hopital's rule, but like way more in depth in BC. And I had a kid like 3 years ago. Every time he did L'Hopital's rule, he used an ambulance. So I knew that he was using L'Hopital's
That's
rule. It was very interesting.
Do you want us to do that?
No, please don't. You can write an L''H, so I know, but then we're good.
It's gonna be
Okay.
I'm gonna draw in little like wee.
Now, don't write this whole paragraph down, but you may want to make a note that these are also indeterminate forms. Okay? Additionally, these are also indeterminate forms. We really might only work with one of these cases today. We'll look at a problem that's 0 times infinity, and then the rest we will save for calculus 2. So we're really just kind of grazing the top layer of L'Hopital. Now, those of you that just came in from your pictures, I'm not going to be able to like stay on this slide this entire time, so maybe like skip a little bit. At least write this down right here. Skip a little bit of room so you can come back and fill in, and then we'll move on. We will have a lot of interruptions today because of the pictures. If you have to get up to leave, just know that you need to find a way to get the notes either from up here or when I post the video next hour, go to the portion of the video that you need to be at. Okay? You know, when they take that NHS picture, a lot of them they take another picture that takes a country. Or if you take your, I think, well, that did take a lot of my kids, didn't it? If you take an academy picture, a lot of them, we'll be flexible.
don't.
You're not in it anymore, right?
Yeah, I am.
You are.
It's okay. I'm on my second strike, so I might not be.
Whoa.
I'm kidding. I just forget to bring khakis, so that's my thing. I'm on my second strike, not wearing khakis.
Okay, so you and Jim Harbaugh, like, you're on opposite ends of the spectrum. You love this khaki and you.
I like to wear shorts and like I don't know. Keyboard voice.
You know Jim Harbaugh is the best.
Kind of.
Khakis.
He's the coach for football.
So also been a stretch.
Well, like college game day, like college game day or something for football, like somebody always has a sign that has to do with football. Like, if it's playing or not. Every week. Okay. Please write down this example. Literally, the rest of the time are examples today. Okay, when you have a limit, you always need to use direct substitution first. If we plug in 0, what is e to the 0 minus 1?
0.
So this goes to 0, and, well, when we substitute in, that goes to 0, okay? 0 over 0 is indeterminate, which means we need to apply L'Hopital's rule. So if we apply L'Hopital's rule, then this becomes the limit as x approaches 0 of the derivative of the numerator is 3e to the 3x. Would you agree? Because of the chain rule? Divided by the derivative of the denominator is what? So now, when we plug in 0, what do we get for our limit? 3.
At this time, we need the following groups to go to the main gym for pictures. National Honor Society, Quiz Bowl, Robotics, Science Club, and Senior Class Officers. Again, that's National Honor Society, Quiz Bowl, Robotics, Science Club, and Senior Class Officers.
If you are getting inducted into NHS tomorrow night, you can be in the picture. Okay. All right. Whoops. Next example. Okay. As we go towards infinity, what happens with the natural log of x? Do you know what the graph looks like? There seemed to be an issue last week when we were sorting our cards. This is the natural log of x. So towards infinity, we rise towards infinity. What about the square root of x? What? Well, no, I'm asking, towards infinity, what happens with the square root graph? It keeps going towards infinity, right? So we have infinity over infinity for our limit. We can't evaluate that. So, since this is one of the indeterminate forms, we can apply L'Hopital's rule. And when we apply L'Hopital's rule, we need to take the derivative of our numerator. Oh, woo, you're kind of making me worry. Over the derivative of our denominator. Huh? Yeah. 1 over radical x. So I'm going to write it like this right now, Sling. So this is x to the 1/2, right? So when we do the power rule, the 2 times 1/2 cancels out and we have x to the negative half power, right? Okay, which is the same thing as 1 over x to the 1/2 or 1 over radical x, okay? Do not try to evaluate this limit until you have simplified. Can we simplify this fraction? Okay, this is the same thing as 1 over x times, let's see, x to the 1/2. Do you agree? Because we're bringing that up, because it's a negative exponent, we bring it up. Okay, so if we simplify this, we have x to what power? Yes, we would have x to the negative 1/2. So we can write this as 1 over x to the 1/2 power. So now we can reevaluate our limit. We have 1 over radical x. Well, we already know that radical x grows towards infinity. So if we have 1 over growing towards infinity, what happens to our fraction? It gets smaller, goes to 0. Since this is growing to infinity, our fraction as a whole grows to 0. Kind of a nice change of pace, right? Like our problems are taking 1 minute instead of 20 minutes. Right? I can stop if you like. We'll do this. And 2 more. And we'll talk about, one's not really an example, we're just going to talk about it. We got a lot of time. A lot of time. All right, when we go towards negative infinity, what happens to x squared? Goes to infinity, right? E to the negative x. Towards negative infinity, what's happening? It's going towards infinity, okay? Please remember that exponential growth, e to the x, looks like this. E to the negative x, exponential decay, looks like this. Okay? All right, so we are going to have to apply L'Hopital's rule. So we have the limit as x approaches negative infinity. L'Hopital says take the derivative of the numerator over the derivative of the denominator. Towards infinity, what happens to towards negative infinity, what happens to 2x? The line 2x, it goes towards negative infinity, right? What about negative e to the negative x? It also goes, dang it! We have an indeterminate form, which means what can we do? We can do L'Hopital's rule a second time. As long as you have an indeterminate form, you can use L'Hopital's rule. So it is possible that you use L'Hopital's rule more than once. Okay, we're going to have to use it a second time here. So the limit as x approaches negative infinity, our numerator has a derivative of 2, and our denominator has a derivative of e to the negative x. Now, we have 2 over goes to infinity. And if our denominator is going towards infinity, then our fraction as a whole is going towards 0. No, these will not all equal 0. Those just kind of a point. Yes, I am going to make you think back to some graphs from pre-calculus and what they look like so you can evaluate these limits. But the algebra is at least less intense than it was in Unit 1. Now, speaking of Unit 1, let's talk about this limit right here. When we use direct substitution, what do we get? 1 over 0. Is that indeterminate? No. Okay, we get 1 over 0. Let's remember what is happening. What is happening at x equals 6? It's an asymptote, okay? And so since there's an asymptote, we would have to look at the right-hand limit and the left-hand limit. But what's happening is we have an asymptote at x equals 6, and on one side we're going up, and on the other side we're going down. And so this limit doesn't exist. Okay? We cannot use L'Hopital's rule on this because it wasn't indeterminate. Okay, I really need you to be thoughtful about if we have an indeterminate form or not. So I really want you to see the difference between 0 over 0, and here we have the 1 over 0, which it's nothing. Okay, my last two examples are going to be the indeterminate form that's not already a fraction for you, okay? You wrote down those other indeterminate forms, and I told you that we were going to focus on one. That 0 times infinity, we're going to do a couple examples that look like that, okay? 0 times infinity is not something that we can calculate, okay? Go ahead and write this down. 0 times infinity, anything times 0 is 0, but any times infinity, anything times infinity is infinity. So we have like two contradictory rules to where we can't actually evaluate the limit. The behavior is too unknown to be able to make either calculation. So here's an example. Towards infinity, we have e to the negative x times radical x. Okay. Well, e to the negative x, like this, right? Towards infinity, what happens? It goes to 0. E to the negative x exponential decay. Towards infinity, we're going towards 0, right? Okay. But radical x, we know looks like this. And so our end behavior towards infinity is infinity. Okay. Well, we talked about how this is an indeterminate form. We can't actually calculate that limit. But since it's indeterminate, we can use L'Hopital's rule. Well, go back up to L'Hopital's rule. We have to have a fraction in order to use L'Hopital's rule.
You divide by e back.
Okay. We have e to the negative x. We can easily take that and move it to the denominator, right? So we can rewrite this limit as the limit, as x approaches infinity, of radical x over e to the x. Now we have a fraction where our fraction is going to infinity over infinity. And we can now apply L'Hopital's rule. Where we can take the derivative of our numerator over the derivative of our denominator. And what did I tell you have to do before you can reevaluate your limit? You have to simplify. I have a fraction and a fraction. Pick So you'll do that. Okay. Simplify your fraction before going any further. Okay, so if we multiply by the reciprocal of our denominator, we actually get 1 over 2 radical x times e to the x. Everything is in the denominator together. We multiply by the reciprocal of our denominator, 1 over e to the x. We actually have both of those items in the denominator. Okay? Well, towards infinity. 2 radical x goes towards infinity. E to the x goes towards infinity. So we have 1 over really going towards infinity. So this limit's going to 0. I promise my next example will not be a limited. Questions before we go to our last example? Haley, do you have a question? Are you sure? Then we will do our last example as a class. This one's really confusing for me. Towards infinity, what's the limit of x? Y equals x looks like this. What's the limit towards infinity? What's our end behavior? Just x. Just this right here. Y equals x looks like this. What's the limit towards infinity? Okay. Okay. Sine of 1 over x. Well, 1 over x towards infinity. Okay, we've been talking about how that goes towards 0, right? Well, what's the sine of 0? Yes. So we have our indeterminate form of infinity times 0. Well, we actually got to make this a fraction. Okay. In order to use L'Hopital's rule for an indeterminate form, we have to force it to be a fraction. Okay. In the previous example, we had a negative exponent that was really easy to move down. We don't have that here, but we do have an x to a power, right? And what can we do with that x to the power? Yeah, we can move it down. Yeah, so we can say that this is sine of 1 over x divided by x to the negative first. So now we've forced it to have a negative exponent, just because we need the fraction, okay? And x to the negative first is the same thing as 1 over x. This might help you see what's happening more clearly. So we have an indeterminate form of 0 over 0. Okay? Now we can apply L'Hopital's rule because we have an indeterminate form that is a fraction. Okay? All right, fun stuff. What is the derivative of sine? And then we have to apply the chain rule. The derivative of x to the negative first is negative x to the negative second. Okay? Coincidentally, our denominator is x to the negative first, and its derivative is negative x to the negative second. That worked out nice, right? Before we evaluate, we need to simplify. Welcome back. Okay, so these cancel out. We already talked about 1 over x towards infinity goes towards 0. And so we have the cosine of 0, which equals 1. Yeah. No idea.
At this time, we need the following groups to go to the main gym for pictures. Science Club, Spanish Club, STEM Academy, and Student Council,
Good to see ya.
and also Skills USA. Again, that's Science Club, Skills USA, Spanish Club, STEM Academy, and Student Council.
That's up to you. So, if you leave your stuff